Welcome to lesson 7.2. We're going to cover several different topics in this lesson, but we're going to start out with something you should have learned about last year. And it's I'll do it this way, SecMath3. Now, hopefully this sounds familiar to you. If not, that's okay, we're going over it right now. But this is definitely something that needs to be memorized. You need to memorize this little phrase, SecMath3, because it tells you how to write your three trig equations. Now let me tell you how to translate this phrase into an equation. We start with the first letter. In this first part, it's an S. So that S stands for sine, or S-I-N. Now, full thing is S-I-N-E, but we abbreviate it with just the first three letters. Now, after you put your first letter, so in this case sine, you will always put your angle in parentheses, an equal sign, and then a fraction. Always, always. Those parts stay the same. Now, just so you know, that right there is called theta. It's just a Greek letter. It's basically just a variable. You could think of it as an x. Theta is just a variable. That's all it is. Now, the second letter, so in this case O, that tells you the numerator of the fraction. So that O stands for opposite, which I'll tell you what that means in just a second. And then this third letter is the denominator of your fraction. So in this case, it's an H, which stands for hypotenuse. Now, let's do the second part of the phrase, ka. So once again, that first letter is a C. In this case, it stands for cosine, which we shorten to cos. Just use the first three letters. And then we always have our angle, theta, and equals, and a fraction, just like the first one. Now, the second letter in this grouping is an A, so that's our numerator, and A stands for adjacent. And the third letter in this grouping is an H, which stands for hypotenuse, so that's our denominator. Last grouping, TOA. This big T stands for tangent, which we shorten to tan. Just use the first three letters. And then just like the others, we always have our angle in parentheses, and equals, and a fraction. The numerator of our fraction is going to be an O, because that's the second letter, so opposite. The denominator is going to be an A, that's the third letter, so adjacent. That's why it's so important to remember this SecMath3, because it tells you how to write these equations. So let's do this one example where we apply it. So let's start by looking at this picture right here. You'll notice that there's a theta. That theta means this is the angle I'm focusing on. This is the angle I care about. Now, before I start any of this, I actually want to label the sides on this triangle, and this is exactly how you do it. First step is to find your right angle. Next, you're going to go across from your right angle, and the side that is across from your right angle is your hypotenuse. So in this case, our hypotenuse is 13. Our next step, find the angle that you care about, and you're going to go across from the angle we care about. The side that is across from the angle we care about is our opposite side, because it's opposite the angle we care about, or across from. Now, the last side that we have, this 5, that is your adjacent side, because it's adjacent or next to my angle. And I would always label your triangle exactly that way. Go across from the right angle, that's your hypotenuse. Across from the angle you care about, that's your opposite. And then the side that's left is adjacent. So now if we look at these, so first off, let's add our fractions in. So I know that sine is the opposite side over the hypotenuse side. So let's fill that in. Well, in this one, the opposite side is 12. And the hypotenuse side, right there, is 13. So this one, our answer is 12/13. That's the sine value. Our cosine is adjacent over hypotenuse, so co. So if I look at this triangle, the adjacent side right there is 5. The hypotenuse side right there is 13. And there we go, that's our answer. And then finally, tangent is TOA. So O on top, A on bottom. So for this triangle, our opposite side right there is 12. And our adjacent side is 5. So that's our tangent. And there we go. Now, you'll see these over here. Cosecant, secant, and cotangent. This is another thing you're going to want to memorize. First off, you need to remember that cosecant, which we shorten to CSC, so let's write this above, cosecant, is paired with sine. Always, always. Cosecant is always paired with sine. And here's what I mean by paired with. If I take that sine value, that 12/13, and I flip it, that's the value of my cosecant, 13/12. That's what I mean by paired. If you take the sine value and flip it, that's the cosecant value. Same thing with cosine and secant. Let me write out what that one is. Secant. So for the secant value, I just take the cosine value and I flip it. So instead of 5/13, I get 13/5. And that's my answer. And same with the last one. Tangent is paired with cotangent. That one kind of comes pretty obviously, tangent and cotangent. So I take the tangent value, which in this case is 12/5, flip it, and that gives me my cotangent. So 5/12. And there we go. Now, you do need to memorize what these ones are paired with. So a little trick I've used is I remember the S goes with the C. Because I used to think, well, the S's should go together, so sine should go with secant. But it's flipped. It's opposite. So sine goes with cosecant. S and C goes together. Cosine goes with secant. S and C go together. And then tangent and cotangent go together because they sound like they should. Okay, so that is it for our first video. In our next video, we'll do a couple more example problems using this SOHCAHTOA stuff.